These ruins in the Roman Forum are a reminder of empires that have fallen, but they also hide a much older killer. Since the days of antiquity, a single disease has stalked humanity, and in 2024, it claimed 610,000 lives. We often focus on the mosquito as the primary source of this death toll, but the insect is actually an airborne vehicle for a far smaller passenger. The actual culprit is a microscopic parasite called Plasmodium falciparum. To survive, this single-celled organism executes a complex biological heist, surviving and exploiting the immune systems of two entirely different species. The invasion begins at night. A female Anopheles mosquito lands, piercing the skin and injecting an anticoagulant saliva to keep the host's blood flowing. Hidden in that fluid are infectious parasites called sporozoites. With a single bite, hundreds of these invaders are pumped directly into the human bloodstream. They move with startling speed. To evade immune detection, the sporozoids race through the vessels and reach the liver in under 30 minutes. Once there, they breach the walls of individual liver cells to hide and begin their next transformation. Over the next week or two, a single parasite multiplies asexually into thousands of clones, swelling the host cell until it is near a breaking point. During this massive biological buildup, the human host feels entirely healthy. This silent phase makes the infection nearly impossible for a victim to detect until it is ready for the next stage. The illness officially begins when those liver cells burst, releasing a wave of newly formed parasites called merozoites into the blood. These merozoites aggressively target red blood cells, invading and hijacking them to continue their rapid multiplication. The parasites operate on a synchronized biological clock, meaning vast numbers of hijacked red blood cells rupture at the exact same moment. This temperature graph shows the result. Every coordinated cellular explosion triggers the trademark symptoms of malaria: cyclical fevers, violent chills, and severe anemia. Amidst this chaos, a few parasites transform into sexual cells. These drift into the tiny capillaries just beneath the surface of the skin. The parasite has successfully turned the human body into a walking reservoir, positioned perfectly for the next phase of its extraction. The extraction begins when an uninfected female mosquito bites the sick human and vacuums up those specialized sexual cells. Inside the mosquito's gut, the parasite enters its only phase of sexual reproduction, shuffling its genetic deck to create new biological variations. These newly formed infectious parasites then migrate from the gut up to the mosquito's salivary glands, where they lie in white. The mosquito is now a carrier, closing the loop, and resetting the transmission cycle for a completely new victim. The entire global strategy to defeat malaria revolves around severing this specific, unbroken transmission chain. But the environment is changing. As the world warms, the parasite's intudation speed inside the mosquito accelerates, while their habitats expand into previously safe regions. Progress has also slowed because the parasites are evolving. Chloroquine and other primary drug treatments are now facing widespread biological resistance, allowing the disease to survive our best medicine. To break the cycle at the point of delivery, we are deploying next-generation treated nets, creating a physical barrier to prevent the bite. To break the cycle during the blood phase, new vaccines are rolling out to millions of children, stopping the parasite's multiplication before illness takes hold. Because we can now target every step of this biological loop, the World Health Organization has issued a global rallying cry for 2026. Ending malaria in our lifetime is now a real possibility, and as the campaign says, now we can, now we must.